Stanford University.
Okay, well, welcome to Lecture 6 of Stanford CS 193P, winter of 2015. So today I'm going to do a little bit of demo action right at the beginning. I want to show you kind of a cool trick that you can do inside your storyboard. And we also, last time, didn't get to the point where we had actually a model for our MVC, our happiness MVC. We had worked on the face view and we got that working, but we didn't have a model. So I'm going to just put that model in there. But then I'm going to jump right back into the slides, and I'm going to cover a very important concept, which is delegation. And I'll have to kind of go over Swift's protocol syntax. And then I will do a demo to show you how that works, how delegation works. Then I'm going to cover gestures. Okay, we know how to draw in our view now from last time, so now we're going to then talk about how we handle gestures, pinches and pans and swipes and things like that. And I think that'll probably use all of my time up, but if I have a little bit of time at the end, I'm going to get started on the next major topic, which we're going to spend most of Wednesday on, which is multiple MVCs, right? We know how to build an MVC. It's got a controller, it's got a model, it's got a view, and now we're going to build a bigger application by combining MVCs. Okay, and that's critical, obviously, to growing the capability of size of app you can build. So I'll try and fit in 5 or 10 minutes of that, of slides for that, just to make sure we have more time on Wednesday. Anybody have any questions about any of this? All right. So let's dive into this demo first before I talk about that. Okay, so I'm just going to bring up happiness from where we left off last time. And really all we had done here was the face view, right? We hadn't done our happiness view. In fact, if I switch over to our happiness view controller here, you can see it's completely empty. One thing we're going to do is fix our model here, but before we do that, I'm going to show you something really cool that you can do in storyboards. So here we have our storyboard, and it's pretty blank. It looks blank. This is big blank square here. This is our face view in here that I have selected. You can see the little resize handles for it are selected, but I can't even really tell that's a face view, and it's hard to tell where it is, and it's just kind of hard to tell what's going on. And it's actually possible, believe it or not, to have your custom UI view subclasses draw in your storyboard. Okay, so they can actually be live drawing in your storyboard, and it's really incredibly easy to do. I'm just going to go back to my face view. Here it is, and right before the class here, I'm going to say @IB designable. And if I pt @IB designable in there, then when I go back to my storyboard, just Xcode automatically notices that's an IB designable class, and it will draw it right here in the storyboard. So now I can see much more easily what's going on with my face view, where it is here. And if I change something in my face view, like let's go change that smile so it's not a frown. Whoops, where is that? That's here, right here, -0.5. Let's change that to +0.5. Okay? Then it'll notice that this file is changed, and it'll kind of recompile it and then redraw it. Okay, so you're always seeing kind of the latest version. Now another thing that would be really cool here is, just like if we have a button or a label, when we bring up the attributes inspector here, we can edit attributes of a button or a label, right? Like its alignment or its font. Well, wouldn't it be cool if we could edit the attributes of this face view here as well? And we can do that too. If we go back here to the face view, here's some of the things that are settable about a face view: the line width, the color, and the scale. And you can make any of these things that you want to be editable inside of your storyboard by just putting in here IB inspectable. If you put IB inspectable before them, then Interface Builder, which is the part of Xcode that's doing your storyboard, will create a UI to make all those editable. So let's go back to our storyboard here. Here's our storyboard. Now, if you look over here, you can see face view. It's added things to be able to set these. I can set things like my line width. Maybe I want thicker lines. Maybe I want a different color. So we can go to the color chooser here. We could pick, green color or orange or something like that. Tangerine, that looks good. And we can change the scale as well too. We'll go down to 0.5, maybe we want to go 0.95. All right, we can change that. Now, these are not only changing here in your storyboard, but they're actually setting the default value so that when you run your application, so let's go ahead and run our application here, it's going to use these values that are set in the storyboard, just like if those were buttons or labels and you had changed something about them in the inspector, it's going to change the way it works in your program as well. Yeah, questions?
So that overrides your what's in your code?
Yeah, so the question is, does that overwrite what's in our code? So for example, back here, we had equals 3, we had equals blue color, and the answer is yes, it overwrites it. Basically, when interface bidder loads it up, it respects those, it'll use those, but then as soon as you start editing them, then it's going to, when you run, set them to the edited values. Any other questions about that? Question?
Are there any gotchas for IB designable? Like, why wouldn't you always want that?
Yeah, so the question is, are there got to be some gotchas or something? Why wouldn't just IB designable be the default? And yeah, there are some gotchas. You know, there are certain things that really it can't do. It can't, you load your code up, you might have dependencies on other frameworks that it can't see, things like that. So yeah, there are some gotchas. I don't have time to go through them all, but I just wanted to show you that this is here. For most straightforward subclass UI view, it works great without gotchas. But yeah, there are obviously some times when it's not going to work because you could have a complicated view. And so any other questions about it? Okay, so that's it. That's all there is to know about that. And so let's go back to our model here, or to our controller. And I want to put the model in here. For the happiness view controller. So its model, because this is demo, right, and I want it all to be really quick, and so you can even follow along with me, some of you. This model is going to be really simple. I'm going to have the model of, and a model, you know what the model is, right? Your calculator's model was a calculator brain, so it was a whole object that you created to be the model. Here I'm going to have my model be the happiness, and it's going to be the very complicated data structure of an int, okay? So we're going to represent our happiness as an int. And I'm going to start it out at 50, and I'm going to have my happiness mean 0 is very sad, and 100 is ecstatic. Okay? So that's my model. Super duper simple model. And don't get this model confused with the smiliness in the face view. That's a different thing. That's just the angle of that arc in the face view, totally separate thing. And you notice they're kind of on different scales anyway. This is 0 to 100. The smiliness is -1 to +1, etc. And that's okay, because one of the things that controllers do, one of their jobs really, is to interpret the model for the view, okay? Or vice versa. Input happens in the view, and they have to figure out a way to communicate to the model. That's a lot of what a controller does. And so we're going to have some code in here that does exactly that. It interprets our 0 to 100 happiness into a smile or not. Now, there's other things that represent happiness besides smile, you know, little crinkly eyes and other things that make you appear that you're happy, but we're just going to use our face view, which only knows how to smile or not. Now, one thing that we can do inside this model, I put the curly braces here, and you might say, why did I put that there? That's because I want to use the property observer for my model to essentially validate it, to validate my model. So you can use these property observers to do validation, really, of any property that you want. So my happiness can only be 0 to 100. If someone passes me happiness -1 or 5,000, I need to kind of keep it in range to 0 to 100. So I'm just going to say in my setter here, my property observer here, I'm going to say min-max of my happiness to 0 or 100. So I'm just keeping it between 0 and 100. Right? So no matter what someone passes me, my happiness will never be outside of that. Again, this is kind of a trivial example. You might have a much more powerful model that needs much more powerful validation than this, but you can see this as a place to put it. Another thing you might want to have here is if someone updates your model, you might want to update your UI. Okay? So I'm going to have update UI, and I'm just going to have a function down here, update UI, and it's going to do something to update the user interface. And that's a common thing. When your model changes, you want your controller to cause the UI to be updated. Okay? One thing I'm going to put in here also is a little println, happiness equals, oops, Happiness equals / happiness, just so we can see our happiness changing in our console all the time as we work the rest of the demos. Okay, so we'll work on this update UI piece when we get back to the demos, but I just wanted to show you the model of happiness. So right now it's not hooked up to its UI, so if I run my application right now, you'll see that this is not happiness of 50. This is happiness of, this is not even looking at the happiness. I can change this to anything I want, and it's not going to change this. And so later we'll show you how we hook up our UI to our model through our controller. That's one of the main things the controller does. Okay, so let's go back to our slides though, right here. And I'm going to start with this miscellaneous topic here, kind of a bonus topic, which is extensions. So this, you read about this in your reading assignment, so you know what this is. Hopefully you've been reading those reading assignments. But I'm just covering it here in class, not as much because it's an important feature per se, but it can be a little bit of a dangerous feature, so I just want to cover it a little bit. So an extension is really simple. It's just a way, a little syntax, to add methods and properties to existing classes, structures, and enums. Okay? You do not have to have the source code to those things you're adding it to. You can just add these methods and properties pretty much at will. There are some restrictions. One is that you can't add via an extension a method or a property that already exists, right? So it's not a way to replace it. This is not subclassing. Okay, you're not replacing an overriding methods. So this has to be something where the property or method you want to add to a class does not exist. The second thing is that any properties you add cannot have any storage. Okay, so they can only be computed properties, right? The get, set kind, that's the only kind of property you can have. Okay, but inside an extension, otherwise, it kind of looks like you're in the definition of the class. You can refer to self if you want, and that'll be the thing that you're extending. It's a pretty powerful feature, actually. This feature is easily abused, however. People putting all kinds of adding methods to classes, making it so it's completely not understandable what that does anymore. It's also, you know, whoever designs a class thinks a lot about its API and what should be in it and what shouldn't, and now all of a sudden things are being added. That's kind of weird. This is really best used for beginners like you who are just starting with Swift to add little helper functions to enhance the readability of your code. Okay, so if there's something that it would be really great if a CG-rect could do this little thing, you could add a little extension to a CG-rect to do that. Or maybe a UI view controller just wants this extra little property that it can calculate about itself. That's the kind of thing you could use it for. Now, extensions actually can be used by advanced Swift users, by architects, software architects, to really organize all your code. Because you can put almost everything into extensions and use extensions as basically groupings of functionality. So it's really a powerful feature, and I don't want to make it sound like it's only for little kind of drips and drabs and tiny little helper things. It can actually be used as a core foundation of how you architect, but that does require someone to sit down and have an architectural plan to do that, and you obviously are a little early in the game to be doing that. So I would say when in doubt, if you're not sure whether you should make something an extension, don't do it for now. Okay, and over time you'll get more comfortable with it, you'll understand what to do. And again, the syntax for it is all explained in the documentation. Maybe in the demo here, I'll try and throw one in so you can see what it looks like. Okay, so that was just an aside. Now let's get back to the main guts, okay? This very important feature called delegation. I have to teach you about protocols first. Again, you've probably read about this in reading assignments, but I want to go over it anyway. A protocol is basically a way to express your API a little more minimally. Not to drag in so much API by, for example, having an argument to a function be a class, where now you're passing an entire class into that function. Who knows what that function might do with that class? Okay, it can access the entire non-private API of that thing. So really, the function just wants to use this one method of a class. Protocols are a way for the function to express, oh, really, I just want you to pass me something that can do this one function, because that's what I'm going to call in here. So it's a way to kind of minimize your API. A protocol is a type. Okay? It's just like a class or an enum or a struct. Okay? It's a type. It can be used everywhere a type is. The type of an argument to a function. A var or a let can be a protocol type. So it is absolutely a type. The only thing that's interesting about it is it has no implementation. Okay? In fact, that's kind of the definition of a protocol. It is a type with no implementation. It only has declaration. So use a protocol to declare various properties and methods, but it has no implementation. The implementation is provided by other objects that conform to the protocol. Okay? And there might be hundreds of objects that will conform to a certain protocol. Okay? So, but protocol, when you use it, looks just like a type, exactly like a type as you're going to see here. Now there's three aspects to a protocol, to using one. One is the declaration of the protocol. This looks a lot like declaring a class or an enum or struct. It's just that there's no implementations for any of the properties or methods. Then there's the declaration part where a class or a struct or an enum says, I will implement this protocol. So it declares that it will conform to or implement this protocol. And then there's the part where that class, struct, or enum actually implements the protocol. So it implements all the properties and methods in the protocol. That's required, all of them. Okay, so let's see what that looks like in some code. So here's a declaration of a protocol itself. Okay, this protocol is called some protocol. All right. This protocol has really what some might call inherited protocols, or protocols it inherits, which are other protocols that if you want to implement some protocol, you have to implement those too. Okay, that's what this colon thing. So it kind of looks like a superclass kind of thing, but there can be multiple of them. But it's not really inheritance per se, like you think of in classes. It's more just saying, if you want to implement some protocol, you also have to implement inherited protocol 1 and inherited protocol 2. If you don't implement those, then you haven't implemented all of some protocol. Okay? Now, you have to specify when you do a property, you don't put the implementation there, but you have to specify whether this is a get-only property or it's a get and set. Okay, system needs to know whether it's a set because structs and enums are value types. It needs to know when they're being mutated so it can copy them, etc. Okay? Any functions that are expected to mutate also need to be noted with this mutating keyword. Okay, you probably read that. In the description, you know that structs and enums, since they're value types, the system needs to know when a function is actually changing them so that they can, basically, so they can copy it on demand. It is possible to limit your protocol to only work with classes. You put class, the word class, right after that colon. So some protocol colon class means this protocol can only be implemented by a class. It cannot be implemented by a struct or an enum. Okay, then you wouldn't need any mutatings because a class, since it's a reference, passed by reference all the time, you can obviously mutate with any method or property. Okay? You can even specify that a protocol requires the class or struct or enum to implement a certain initializer. Okay? That way you know that you can create one of these things. All right? So that's kind of cool too. All right? So that's how you declare a protocol. You can see it's pretty straightforward. No implementations in here, right? All right, so now let's talk about the part of it where it says, I'm an implementer. I want to implement this protocol. How do I tell the world I'm going to implement this? Okay, and you do that by putting at the end of the declaration of the thing, so here's class, some class that inherits from superclass of some class. You just put a comma and all the protocols that this class is claiming to implement. Okay? Now, obviously, if this was a struct or an enum, it wouldn't have that superclass thing. So it would just be colon and then the list of all the protocols that it is claiming to implement. So this enum, it says it's going to implement some protocol and it's also going to implement another protocol. And once it says that, it has to do it or the compiler will not allow you to compile. Okay? Same thing with a struct, right? So pretty straightforward syntax there. The number of protocols is unlimited. You can just keep putting more and more protocols that you say you'll implement. In a class, if you implement an init in a class, you have to say it's required. Okay? So that's because you wouldn't want a subclasser using the rules of inheritance of initializers, which we talked about in depth last lecture or the one before. It could get to a situation where that init is not even implemented, okay, in a subclass, and that would be no good because you're saying you conform to this protocol, and then that init is part of this protocol, so you have to make them required. Okay? You are allowed to add protocol compliance or conformance with an extension. And this is very common to do, again, in a bigger architected system, is you will implement the entire implementation of a protocol on some class or structure enum by implementing it as an extension. Now, the only thing about that implementation is, of course, no stored properties in there, only computed properties. So you would have to be able to implement that entire protocol without any storage. But a lot of protocols can be implemented without storage because they're fairly simple protocols. Okay? So here's what it looks like to use a protocol as a type. A protocol is just a type. So I've created a protocol here called movable, and it has one function in it, move2, which presumably moves the thing. It's a mutating thing that moves the thing. And then I've created two things, a class called car, which is a movable, so the car can be moved, and a class called, or struct rather, called shape, which can be movable. So this might be a graphical shape that can be moved on screen. Now you see that car and shape are completely different kinds of things, but they both could be moved, so they both could be movables. And you can see that they both properly implement the movable protocol, and they both claim to implement movable. Then I've created a couple of little variables here, Prius and square, which are just instances of car and shape. Okay, so now let's look at some code. I can create a variable called thing to move. It is of type movable. That's a protocol, but protocols are types. And I can set it equal to Prius. This is completely legal because a Prius is a movable, right? It implements the movable protocol, so I can set a variable that is movable to a Prius. Works great. I could then say thing to move, move2, because thing to move is anything that implements the movable protocol. However, I cannot say thing to move dot change oil. Okay, change oil is a car thing. It's not a movable thing. Okay, so I can't send it to a movable. Even though, yes, that thing to move happens to currently contain a car, it's still, the compiler won't even let you put this in. It'll complain. It'll say thing to move is a movable. Movables don't understand change oil. You understand? Okay. I could then say thing to move equals square. That's perfectly legal as well, because a square is a movable. It implements that protocol, so it can do it as well. More interestingly, I could let things to move be an array of movable, and I could set it equal to an array that has a Prius and a square in it. So it's got a car and a shape, a class and a struct, all in this array, and that's perfectly legal because they're both movable. So I can create an array of them because movable is a protocol. It's just like a type. Okay, it is a type basically. Okay, make sense? Why I can do that? All right, I can also have a function like slide. Let's say that slides something along the ground or something, and it can take an argument which is a movable. And then inside of it, I can say move2, and that works fine. And I could say slide Prius, slide square. All works fine because they're all movables. It's actually possible to declare an argument like slip and slide that implements that takes an argument that has to implement two separate protocols, movable, but also something called slippery, let's say, which I haven't defined. Okay, so this little thing where you say protocol angle bracket and then as many protocols as you want, close angle bracket, that says this argument to this function has to implement both of those protocols or all of those protocols. And then if I tried to say slip and slide Prius, that would not even compile because while Prius is a movable, it's not a slippery. And so it can't do that. It can't be passed through that argument. Okay? Everyone cool with protocols? Any question about that before I start talking about delegation, which uses protocols? Okay, so delegation is a very important use of protocols. Delegation, if you remember back to our MVC talk right at the beginning of the quarter, we had this big graph, and one of the things we showed is how views need to be able to talk back to their controller, okay, but views are generic. So they can't know anything about the class or the controller that's using them. They're generic building blocks. Okay, so how do they talk back? Well, it turns out they talk back using protocols. Okay, and this is called delegation. Okay, so let's talk a little bit about how that works, how it plays out to do delegation. First, you're going to create the delegate protocol. So the delegate protocol is just going to be protocol something with a bunch of methods and perhaps even properties, and it's going to describe what the view is looking for someone else to do for it. Okay. It's going to describe the responsibilities the view is going to delegate to someone else. Okay? So if this is a scroll view, something in the protocol might be should scroll to point. The view wants to know, should I scroll to this point? The user's trying to scroll to this point. Should I do it? And the view doesn't know because it doesn't own its own data. It doesn't really even know what it's scrolling on, so it needs to ask someone else. So it's going to create this protocol anytime it either needs to notify someone else that something interesting is happening or ask someone else for permission to do something or to try and get its data, okay, which is a common thing. It wants its data that it's trying to draw, but it can't own its own data. Remember, views can't own their data. The data is owned by the controller. Really, it's probably in the model, but the controller is responsible for dishing the data out. So the first, you're going to create that protocol. Then you're going to create a property in your view, okay, called delegate, or sometimes it's called data source if it's delegating the data. And the type of that property is this delegation protocol that you're going to create. Okay, remember, protocols are just types, so that's what the property type is going to be. Okay, then it's going to use that property to go do all the delegation. It's going to send a message to the delegate property saying, should I scroll to this point? It's going to send a message to this delegate property, maybe it would be called data source in this case, but it's saying, hey, where's my data? Give me more of my data. Okay, that's what it's going to send, and it's going to send it to this object right here, this delegate property. And this delegate property, all it is a protocol, so all that anybody who implements that protocol can be set as the value for that delegate. All right, then the controller is going to come along, and it's going to first say that it implements that protocol. Okay, so it's in its class thing, it's going to say, yeah, I implement this views delegate protocol. Then the controller is going to set itself as the delegate. So it's going to set that delegate property inside of the view to itself. Okay, which is fine because it just said it implements that protocol, so that's good. Then, of course, the controller is going to have to implement the protocol. It's going to implement all the methods and properties required by the protocol so that it conforms to that protocol. Otherwise, the compiler is going to complain. And you're good to go. Now the view is hooked up to the controller. Okay, but the view still knows nothing about the controller. It doesn't know what class it is. It doesn't know what its purpose in life is. It knows nothing. All it knows is it implements the methods in its protocol, in the view's protocol. That's all it knows, and that's all it needs to know. Okay, so that keeps the view completely generic and allows the controller to have complete control of this generic minion in its view. Okay, remember, the view is the controller's minions. It's how it's communicating with the user. Okay, so that's how we do it. All right, so let's take a look at a demo of doing that in Happiness. We're going to have the face view delegate getting its data. Its data is basically its smiliness, how much smiliness is going on. It's going to get that from a delegate. All right, and of course the Happiness view controller is going to be the delegate it gets it from.
Okay, well, let's now use delegation to hook up our face view to our Happiness view controller. And we're going to do that by starting here in the face view, and we're going to go through the same steps we just talked about in the slides to do delegation. So remember, the first step is that we need a protocol, some particular way that the face view is going to talk to whoever is going to provide its data. And the face view's data is really its smiliness. So the face view has this data. Now this is a very, very simple data. Probably in real life, if this weren't a demo where I'm trying to show you delegation, you would probably just set this. Even though the view can't own its own data, it's such a simple piece of data. But we're going to use delegation to get this piece of data here, rather than have it be set right here. All right, so we need some sort of protocol that gets this smiliness from someone. And so we're just going to type in here protocol. And I'm going to call this protocol that I'm developing my face view data source protocol. And sometimes we call these delegation protocols delegate, like face view delegate. But when the only purpose of the protocol is to get the data that the view is going to draw, because the view can't own its own data, then we oftentimes will call the protocol data source. So this just needs to have whatever functions and properties are required to get this view's data. Well, it's such a simple view that it really just needs something to get the smiliness, some function. And I'm going to say smiliness for face view. I have an argument here, which is the sender, face view, and this is going to be myself. So when I ask somebody else to provide my data by sending him this message, I'm going to pass myself, this face view, along as an argument. And you'll see all throughout iOS when they have a delegate or a data source, they're always going to pass themselves along. So that you know, if you're trying to provide the smiliness for this face view, you have a pointer to the face view to know which face view is asking you that, and maybe if you need to ask the face view some other questions to answer this, you can do that. Now, this smiliness, what's it going to return? Well, I'm going to have it return a double, which is going to be the smiliness. Remember that smiliness goes from +1 down to -1. +1 is very smiley, and -1 is very frowny. And so we need that double. I'm also going to make this double be an optional. Now, why am I going to make that an optional? That's because if the data source, if I ask it for the smiliness and for some reason it can't provide that smiliness, then I'm going to allow them to return nil, and then I'll just maybe just have a, you know, no smile and no frown, just kind of flat-lined mouth there. Now, we only, by the way, pass one argument here, but we could definitely, if we were asking our data source, we could have some more arguments in here, and so that's perfectly reasonable. You can have as many arguments as you need to get this smiliness out of the data source. Okay, so that's step one. We have this data source here. Step two is we need to have a public var in our face view, which I'm going to call data source, and it's going to be of type face view data source. Okay, I'm going to make that an optional as well. And so you can see here that I'm using face view data source, which is this protocol, just as a type. And what this means is somebody who wants to provide my data, who wants to be my data source, all they need to do is set themselves as this variable. And then I'm going to talk to them through this variable to call this function on them. Okay. Now, why did I make this an optional here? Because it's possible that I can just live without a data source. I will just always have a flat line, a flat mouth. I won't be smiling or frowning. And so this can be allowed to be nil. Okay. Now, normally this is not going to want to be nil because we don't want just a face with a no frown and no smile. But you know, we certainly will allow it. So we're going to allow that there. Now, one other thing we have to do about this data source here is we really want to describe it as weak. Now, this is going to be the first time we really talked about memory management in this class, and really the memory's just been managed automatically for you. But here we have to be a little bit careful with the memory management of this pointer. Because, for example, our controller is going to set itself as the data source, so it's going to set this pointer back to itself because our controller is going to be a face view data source. And unfortunately, the controller also has a pointer to this face view through the view hierarchy because it's going to have some outlet to the face view. And so they'll be pointing to each other. And since they're pointing to each other, they're keeping each other in memory at all times. So that's, that kind of memory cycle is really bad because then the face view and the controller can never leave memory. They'll be stuck in memory forever. So by making this weak, if we put weak in front of a var pointer, it means that this pointer, that this thing, whatever this points to, should not be used to keep it in memory. So the controller is going to set itself as this data source, but this pointer, since it's going to be a weak pointer, is not going to keep the controller in memory. So the controller will be allowed to go out of memory. And when it goes out of memory, of course, the face view will also go out of memory with it because its entire view hierarchy, the controller's view hierarchy, will go out as well. And now you can see that we have an error here, okay? And this error says weak cannot be applied to non-class types. Okay, so face view data source is a protocol, not a class. So face view data source could be an enum or a struct. And that's a problem because we really need this to be weak because we don't want that cycle things pointing back to each other. So we can actually make face view data source, even though it's a protocol, we can make it be a class type. If you remember from the slides, in our protocol declaration, we can say :class. And that says that face view data source can only be implemented by a class. It cannot be implemented by a struct or an enum. And that's perfectly fine, and usually that's what we're going to want anyway, but we definitely need that so that we can have this weak behavior. So this data source, the pointer it has to whatever its data source will not keep its data source in memory. Okay, so as long as the data source is in memory, this pointer will be good. As soon as the data source goes out of memory, then this pointer will be set to nil automatically by the system. So it's pretty cool. Weak variables are pretty cool. You don't use them a lot. You saw that we use them for IB outlets, and this is the second place we use them, which is for delegation. We're always going to use a weak var when we have delegation. Okay? And that just requires that we make our protocol only work with classes. All right? Okay, so now we have this nice data source right here. Let's go ahead and go to the next step, which is to use the data source to get our smiliness. Right? So we have our smiliness right here. It's currently a constant minus 0.5. So we're going to get it from the data source by just saying to the data source, please give us our smiliness for face view self. Okay? Now when I type that in, Swift automatically put this question mark here. I didn't type that. It put it in here. Why did it put here? Well, it put it here because data source is an optional and it could be nil. Okay, this is an optional, it can be nil. And so Swift is assuming that we want to use optional chaining here. And just if this is nil, then this whole rest of this expression is going to be ignored. This whole thing would be nil, and smiliness here would be set to nil. Okay, but smiliness, you can see this error here is because smiliness, it can't be nil. It has to be a double. So we're going to use another cool little feature of Swift, which is the question mark operator. And what this operator says is, if the thing on the left-hand side of the question mark is not nil, then use that. But if it is nil, then use what's on the right-hand side. And so on the right-hand side, I'm going to put 0.0. So what that says is that if the data source is nil, then we're going to use smiliness of 0, which is not a frown or a smile, it's in the middle. Now this is also going to be working if smiliness for face view happens to return nil, because you remember it also is an optional right here. It's an optional double. So that'll work perfectly fine there as well. So whether this returns nil or whether this is nil, invalidating the rest of this, we're going to get no smile or frown. So this is a cool little operator there. Okay, so we've got our face view doing its part. It's declaring this nice property, this flush protocol right here. It's got a property which lets people set themselves as the data source, and then it uses that data source to get its smiliness. All right, so now let's go back to our happiness view controller. Okay, the controller has to implement the other side of delegation. Now remember, one of the steps it has is it has to say to the world, I am a happiness view controller and I implement the face view data source protocol. And it does that by just saying face view data source. Now as soon as I put this on here, I'm going to get a warning right here, an error that says happiness view controller does not conform to that protocol. And indeed it doesn't, because we do not implement that smiliness anywhere in our class. So easily fixed though. We go down here. Now since we've already told it implements this, if I just start typing smiliness, it's going to automatically know to escape complete. So I'll hit tab. I've got my nice method here. So how am I going to implement this protocol? Okay, this method in this protocol, how am I going to implement that? Well, the happiness view controller is going to interpret the happiness here, which is the model. This is the happiness view controller's model. It's going to interpret this for the view, because the view doesn't know about happiness, it only knows about smiliness. Smiliness goes from 1 to -1. Here we're talking about the model, which is happiness, that goes from 0 to 100. So it's a typical job of the controller to interpret the model for the view. It'll also interpret the view for the model, and we'll see that a little bit later when we talk about gestures. But here we're going to interpret the model for the view. So I'm just going to return. Now happiness is an int, okay, and the smiliness is a double, so I'm going to have to convert the happiness. Also, the happiness is on a scale of 0 to 100, so I'm going to do minus 50 divide by 50 to convert it into that +1 to -1 scale. So here I'm just interpreting the model for the view. Make sense? Now the last thing that needs to happen here is that the controller needs to set itself as the data source of the face view. And so let's go back to face view. I'm going to show you a nice trick here. You Command Shift and O will let you type in, like start typing face view, and you can see it appears right there. And you can switch really quick. So Command Shift O is a great way to switch really quickly between files in your project. All right, so we need to set this data source right here inside of our face view to be the controller. So for the controller to do that, though, it needs to have a pointer to the face view, and we do pointers to things in our view using outlets, right? So let's go over here to our storyboard and wire up an outlet from this. We'll go to automatic mode up here. Remember, when you go to automatic mode, you're going to see the controller that matches what you have selected in your storyboard. So here we have that. So I'm just going to take my controller right here, and I'm going to control drag to create an outlet. This is the same way that I create an outlet to buttons or to the labels or whatever we've done. It's exactly the same. It's just a normal outlet. I'm going to call it face view. So here's my nice face view right there. Now, where in my code should I go and set this var right here? Okay, this data source var. Well, a great place to do it, since this is what the face view we want to set that in, is right here in the property observer for the face view. Now, this property observer is called when the iOS starts up and loads the storyboard. It connects this outlet. It's going to set this variable. And so it's perfect time when this is being set to go ahead and say faceview.dataSource equals self. Okay, this is the controller. It's perfectly legal for it to say this because it is a face view data source. Right? The happiness view controller is a face view data source, so we can say that it is the data source. It's perfectly fine equals. All right, that makes sense? We're doing that? Okay, so now everything's hooked up, and how's this going to work? It's going to be very straightforward. Every time that the face view draws itself, it's going to look for its data source, which we have set right here in our controller to be the controller itself. It's going to get its smiliness from the data source by calling the method in the protocol up here. Okay, we implement that method in our controller. We interpret the model for the view, and the face view is going to be able to draw the proper value. Now, there's only one other thing that I want to do here, which is every time someone changes our model, I want to make sure the face redraws itself, of course, because we're representing the happiness here in the face. So the best way to do that is in this update UI. So every single time that the happiness changes, I'm going to ask my face view to set needs display on itself. In other words, to redraw. Remember, set needs display is the thing you do that says, hey, call my draw rect, redraw me. Now, if I didn't do this, then every time I set my happiness, the face view would not draw. Okay. Now, maybe if I rotated my device and it redrew, then it would show it. But otherwise, it wasn't going to show it. Okay. So now we've got this hooked up. It really should be the happiness that's showing in here rather than the smiliness. So it shouldn't be a flat line right here. It should actually show the happiness. So let's go ahead and run. See what we got here. Okay, we should get a happiness of 75, which is a little bit happy. Yeah, that looks good right there. Let's go change our happiness here to be sad, like maybe 10. Okay, and rerun. Okay, we're sad. All right, and let's go change it to be ecstatic. And we're ecstatic. Okay, we should be ecstatic because we've successfully implemented delegation.
All right, let's go back to our slides and cover the next thing here, which is gestures. All right, so we know how to draw in a view. Now we want to handle these gestures, okay? You know, pinches and maybe rotations, swipes, taps, things like that. Now, we could get the raw data about every finger that goes down and where it is. That data is available, but we never look at that, okay? Because first of all, it's very difficult to look at that raw data and see, is this a swipe or is this just moving over to the right, okay? So iOS does all that for you, and that's the only way I'm going to teach you to react to user touches is via gestures, okay? So how do gestures work? Gestures are recognized by UI views when the gesture happens inside their bounds. Okay, I told you that views are rectangular areas where you draw and you recognize gestures. Well, this is how it happens. There's a class called UI Gesture Recognizer. It's an abstract base class. You never actually create a UI Gesture Recognizer base class. You create a subclass, some subclass of UI Gesture Recognizer. And those subclasses are concrete in that they know about certain gestures, swipes and pans and touches, etc. So there's two sides to using a gesture recognizer. One is you have to add a gesture recognizer to a view. That says to the view, start recognizing this gesture. If you recognize this gesture, you let somebody know. Okay? And you do that with a function on UI view called add gesture recognizer. Okay? It can be simpler. Then the second piece, though, is when you create the gesture recognizer, you have to say, if you recognize the gesture, who are you going to tell about it? Okay, you have to notify somebody and say, oh, I recognize that swipe. Okay, so there's the handler. So you've got the recognizer, that's the view. Okay, the gesture recognizer in association with a view. And then you've got the handler, that's who handles it. And those are not always the same person. Sometimes they're the same object, sometimes not. Usually the first one, adding the gesture recognizer to a view, is done by a controller. Although a view will sometimes add it to itself. For example, scroll view doesn't even exist without the pan and pinch gestures. That's what it does. So it adds the gesture recognizers to itself. But a lot of times, other times, you have a gesture that you're going to recognize only if the controller wants you to recognize it. So you make some public handler possibly in your view, and then your controller can add this gesture recognizer to one of its views, one of its minions, and say, start recognizing this gesture, and you can even handle it yourself if you want, the controller might say, or the controller might say, oh, and I'll handle it. Okay? So the second thing, the handling, is either done by the view, if it's kind of a display-oriented handling thing, or it's done by the controller, if it's handling something that's going to modify the model. Okay? Or be something that's complicated that's going to cause multiple views to be involved, and so the controller has to do it. And it's perfectly fine to have either the controller or the view handle something, although you would never have the view handle a gesture that is directly modifying the model, because the view can't see the model. Only the controller can do that. Okay? So how do you add a gesture recognizer to a UI view? It's very simple. I'm going to do it in a way that is very common, which is to do it in the property observer of an outlet setter, just exactly like we did when we set the face views delegate in the property observer. When the face view got set, we could do the same thing adding a gesture recognizer. In fact, we're going to do that in the demo. So here I have an IB outlet. It's just a UI view in my storyboard. It's called Panable View, and I'm going to make it so it can pan around in there. All right, and in its property observer there, the did set, I'm going to add this gesture recognizer. I'm going to create a pan gesture recognizer and then add it to the view. So here I'm creating it. This is just calling UI pan gesture recognizer's initializer here. The arguments to the initializer are who to send a message to when the gesture is recognized. When we start seeing a pan, and as the pan is happening, we're going to be sending a message to this object. In this case, it's self. So this method would obviously be in a controller, right? Because the controller is the only things that have these outlets. So this thing is going to be handled by the controller itself. And then action is the name of the method. It's just a string that is the name of the method that's going to be called in the controller when this gesture is recognized. Now, notice there's a little colon on the end there. That means that it's going to call a method called pan that has an argument. That's what the colon means. There's an argument there. Okay? Now, you don't have to have the colon there if you don't want, but if you don't have it there, then you won't get the argument when pan gets called, and the argument you get is the gesture recognizer. And for something like pan, where you're going to try and figure out where the finger is, you need the gesture recognizer so it can tell you where the finger is, basically. Okay? So we almost always have a colon. The only place you wouldn't have a colon might be like a swipe, because a swipe just got recognized. You don't really need any information. You just need to know what happened. So you might have action, quote, handle swipe, no colon. Okay? Then we just ask the view, this panable view, please recognize this gesture when it happens inside your bounds. Okay, that's simple. That's like turning on, this is the on switch for turning on that pan gesture recognizer by asking some view to recognize it. So now every time this view recognizes a pan going on inside his bounds, it's going to send the message pan with an argument to the controller. Everybody okay with this? This is how you set up a gesture recognizer. All right. Now how about the handler? So that pan thing with that argument, how do we do that? Well, for us to handle the pan, we need information about what's going on in that pan, okay? Where the finger is moving, we need to know about that. So the concrete subclasses of UI gesture recognizer, like UI pan gesture recognizer, they add methods that are specific to whatever kind of gesture they are. So the pan gesture one has a translation in view, which tells you how far the finger has moved either since the pan gesture was first recognized or since that last got reset. Okay? And you can reset with this set translation, which will reset this translation to a different spot so that the next time you get notified, it will be the distance between us. So that's a good way to kind of get incremental panning instead of just the total distance that you've panned. And then also I can tell you the velocity. How fast are you panning around? Is the person kind of moving real slow, trying to put something in a perfect spot? Or are they kind of zooming it around? Okay? You might react differently depending on the velocity. So those are things that are very specific to pan. So that's why these methods are in pan gesture recognizer. Now that last one is interesting because of this incremental translation. A lot of people really don't quite understand this, but you'll see when we do the demo, we'll do incremental translation with our pinch gesture, and it'll make a little more sense what's going on there. The abstract superclass, UI gesture recognizer, it also has a very important property called state. Okay? When you have a pan, it actually goes through states. Okay? It starts out in the state possible. Okay? It's possible a pan could happen. Then, if it were a swipe or a discrete gesture, you would just get one state, which is I recognize this. So that's dot recognized. But if it's pan and continuous, then you're going to get began. Okay, it recognizes that the pan has started. You'll get that. And then every time the finger moves, you're going to get another call to your handler saying changed, changed, changed. And then when the finger goes up, you'll get another one that says the state is now ended. So this is basically a little state machine. Obviously, a pan goes through the state machine of possible, began, changed, ended. All right? There's also failed and canceled, like you're in the middle of a pan and a phone call comes in. Okay? That's going to cancel that pan. Right? So sometimes you have to pay attention to cancellation like that, and sometimes not. It depends on what you're doing with your pan. Sometimes your pan is updating whatever there is in real time, and if the phone call comes in, it just stops doing that, and it's fine. Everything is in a perfectly fine state. Other times it might be putting something in some temporary state, and oh, now it's interrupted, it's got to clean up or something. All right, so given this information, what would the pan handler look like? Okay, the pan handler would be a method called pan. It would take one argument, which is the UI pan gesture recognizer itself. You can see right there. Okay, we're going to look at the state machine and say what state it's in. So in my pan, I'm only going to do something when the gesture moves or the finger goes up. I'm not even going to do anything when it first goes down. Okay, I can choose which things I want to do, but that's what I want to do. Hopefully you know about fall through. You read that in the documentation. Fall through is just a thing in Switch that says the implementation of this case is to go to the next one and do whatever the next one is. Okay, so it just falls through to the next case. So in changed and ended, I'm going to do exactly the same thing. What I'm going to do is I'm going to find out where the pan is in the coordinates of the panable view. So its coordinate system. Okay, that's translation in view. I give it the view I want the coordinate system of. It's going to give me the point in that view where the pan is. Then I'm going to update anything I want inside of my controller, because this is being handled by the controller. So I'm going to update anything I want based on that translation, X and Y. Then I'm going to reset the translation. I don't have to do this, but I'm going to, in this case, reset the translation back to 0 so that the next time I get this called, okay, the next time it changes, it's going to be just the difference. Otherwise, it's going to tell me from the time the gesture was first recognized to where I am now. So that'd be a big distance. Well, I just want the incremental difference as I move around. So that set translation to 0 is optional. You can do it if you want. Okay? So that's it. That's how we handle a gesture. Very straightforward. So let's talk about some of the concrete gestures that exist. There's pinch. Okay, pinch, instead of giving you translation, it gives you scale. So when the pinch starts, the scale is 1. If you spread your fingers out twice as wide, the scale would be 2. If you went down to half as wide, the scale would be 0.5. Okay? So that's how pinches work, and it'll also tell you the velocity, how fast the person is pinching. There's also rotation, so that's a two-finger thing as well. You turn in a circle. So it's like you're turning a knob. It tells you how many radians the thing has been rotated, okay? And it'll also tell you how fast, in radians per second, the rotation has happened, so that's the way you can rotate. There's also swipes. Now, swipes are a little different. When you create the swipe gesture, okay, back in the property observer of the outlet, I created the pan gesture, but if I created a swipe gesture there, I would send a message, set the property of the swipe gesture, number of touches required, or swipe direction there, and that determines whether it's a two-finger swipe to the left or one-finger swipe down or whatever. Okay, you just kind of say what kind of swipe you're looking for, and then your handler will only be called once with the state.recognized when that combination of fingers and direction happens. Okay, so that's a little different than these other ones. And then there's also tap. Oh, your question.
Also, for these gestures, I think you cannot test in the simulator, right?
Can you test these in the simulator? Absolutely, you can test these in the simulator. I'll show you.
More than one finger.
Yeah, how do you test more than one finger in the simulator? I'll show you how to do that. So tap gesture is an interesting one. It seems like it would be discrete because it's kind of like swipe. You set up the number of taps and the number of touches, except that if you have a double tap, it'll actually tell you about the first tap and the second tap. So if you're only interested in the actual double tap, you can just look at the state ended because that's the end of that gesture. But if you want to look at the intermediate states, you can actually look at the dot changed states as well. So it's not purely a discrete gesture tap. Okay, so let's go look at how we do gestures by putting some gestures in the face view. So I'm going to put two gestures in. I'm going to put in pinch to change the size of the face. And then I'm going to put in pan to control the happiness. In other words, control my model. All right, with pan. When I move up and down, it's going to be happy is up, sad is down. Not a swipe, but actual pan, so I can move my happiness up in small increments if I want. All right, so let's go back to here, do that. So let's go get some more space here. So we'll go here. So we'll do the pinch first. Let's do the pinch first. So the first thing I'm going to do when I make my pinch happen is to add a gesture recognizer, a pinch gesture recognizer to my face view. And so a great place to do that, as I said, is in the property observer of the face view. So here I can just say add gesture, face view, add gesture recognizer. And this is just any kind of gesture recognizer. I'm going to do a pan gesture, so I'm going to say UI pan gesture recognizer. And then you can see that it has target and action are the arguments. So the target, I'm going to have the pinch be handled entirely by the view. Because all it's doing is changing the view's scale, its own scale. So there's no reason, I'm the controller, I don't need to get involved in that. So I'm just going to have the target be the face view. So the face view is going to handle this pan. Or sorry, we're doing pan? No, we'll do pinch. So we're doing pinch. Do pinch first. So we're doing pinch. We're doing the pinch of scale, not pan, sorry. We're doing the pinch, and I'm going to have the face view handle this because it's just going to modify its scale. And the action, this action needs to be some non-private method in my face view that I can call to handle it. So let's go ahead and go over to our face view and add such a thing. So I'm going to call this method, let's call it scale. Okay? And it's going to take a UI pinch gesture recognizer as an argument, and we'll call that the gesture. And all this is going to do is modify our scale. Okay? Understand? We got this method here? So how is this method going to do this? Well, I'm only going to adjust my scale when the pinch moves. I'm not going to do it when it first goes down because it's going to be scale of 1 anyway. And I probably should do it when the fingers go up, but just to make less code here, I'm just going to do it when it changes. So I'm going to say if the gesture state equals dot changed, okay, then I'm going to take my own scale and multiply it by the gesture's scale. Okay, so if the gesture pinch scales out, I'm going to make my scale bigger. If it scales in, I'm going to make my scale smaller. Okay? And I'm going to reset the gesture scale back to 1 all the time. By resetting it back to 1, then I'm only getting the difference between the last time it told me to update. So that way I can update my scale every time it moves. And since I keep resetting back to 1, I keep getting incremental scale. It's going to keep making my scale bigger or smaller depending on whether the last movement of the pinch was bigger or smaller. This makes my code a lot simpler. So that's it. That's all that's necessary. Okay? And it's typical for gesture recognizers to be this simple, to really not require a lot of code. So this is the name of the handler. So let's go back to our controller and put that in here. So the action is scale, and it did take that argument, so I do need to put the colon there. Okay? And that's it. That's all that's required, so let's go ahead and try it. Now, as was being asked here, how do I do 2 fingers? I only got 1 mouse here. How can I do fingers? And the answer is you hold down the Option key. And you see when you hold down Option, you get 2 fingers. Okay? And they're evenly spaced from the middle. And I can use them to pinch in and out. Okay? Okay? There we go. So you can see adding gestures really, really simple. Okay? You can do other things too. If I can remember here, I think command, what is it? There's other things too. I can't remember offhand what they are. But like you can take the 2 things and move them. There we go. I'm using Shift. Now you can move them up here so that you can expand them out from here or whatever. So you can control them a little bit. It's only 2. You can't do 3 fingers or whatever. So there's some limitations, but you can do some stuff there. All right? So that's good. So now let's talk about another gesture. Let's do a pan gesture where, where if I pan up, it's going to make my guy happier. And if I pan down, it's going to make him sadder. Okay? So I can use a pan gesture for that. Now, I could just go right here and do the same thing. I could say face view dot add gesture recognizer, UI pan gesture recognizer, target. The target would be myself, because if I'm modifying the model with that pan gesture, my view can't do that. The controller has to handle it itself. And we can have the action of this thing be something like change happiness. Take that argument or something. So I could do this, but I'm not going to do it this way. Okay? This would be perfectly fine. But I'm going to show you how you can set up gestures in the storyboard. So you don't even need this line of code. Okay? So here's how that works. We're going to go over here. Let's get our storyboard. And I want to add a gesture recognizer to this view. I do it by going over here, same place where I add things to my view here. If you go down towards the bottom, you'll see that there's tap gesture, pinch gesture, rotation gesture, swipe gesture, pan gesture. Okay? So I'm going to grab this pan gesture and drop it on this view, which says I want this view to recognize a pan. Now, you might say, whoa, where'd that go? I didn't see anything there. What's going on? Where is that thing? It's hard to tell. Well, there's 2 places you can find that thing you just dropped. One is in the document outline. You see it right here, pan gesture recognizer. Another one is right at the top. If you look at the view controller right here, you'll see there's a pan gesture recognizer right there. Okay? Now, all you need to do to make this pan gesture recognizer be handled by your controller is control drag. So I'm holding down control and dragging in here. Okay? Let go. It's an action, kind of like target action for a button, but not quite exactly the same. And I'm going to call this change happiness, because that's what it does. That's what this pan gesture does. Again, type, I don't want it to be any object. This is going to be the type of the argument. I want it to be pan gesture recognizer. If you leave any object in there, you'll have to be using as to turn it in to a pan gesture recognizer so you can use it. But obviously a lot easier just to click it here, the same as we had when we did button action. So I'll hit connect. Okay, here it is right here. Let's go look at it. Okay, change happiness. And now we just need to implement this one. So what do we need to do to change our happiness? Well, the pan is moving up and down, so I can get the coordinates of the pan in the face view's coordinate system, but I really need to turn that into a happiness change in some kind of interpretation. So again, the controller is now interpreting what's happening in the view for the model. So it's going the opposite direction of where we went before. And again, that's the controller's main job, interpreting the model for the view and the view input to modify the model. So how's this going to work? So again, I'm going to do sender state equals dot changed. Now I'm not going to do this because if I do this, everyone out there is going to start doing the same thing. So let's do a switch of this thing. I'm going to switch on the gestures state, and I'm going to handle the case where it ended, and I'm going to handle the case where it changed. Okay, and I'm just going to do them the same. So I'll do this fall through like we did in the slides. So when this pan is changing, or when it lifts up, the finger lifts up, I'm going to try and change my happiness. Okay? So first, let's get the translation of the pan in the face view's coordinate system. And to do that, I'm going to send a message to the sender. You see sender right here? That's the pan gesture recognizer that is being handled here. We call this gesture in the other one, and a lot of people like to change this to gesture, which I think is perfectly fine to want to do. So I'm going to ask the gesture, tell me the translation in the face view's coordinate system. So now I know how much it's moved in the face view coordinate system. And so I'm going to let the happiness change. This is the amount of change that's happening in my happiness. I could just have it be equal to, let's say, translation.y. Probably would want to be minus translation.y because up means happy and down means not happy. But that's going to change the happiness a lot with very small movements. Okay, so I don't really want that. So I really want to have, also it needs to be an int, by the way. So do that. I really want, because happiness is an int, I really want this to change less. So I'm going to actually divide this by a constant. So I'm going to create a constant here. Constants, happiness, gesture scale, I'll call it. Then we'll go back up here and do the private struct constants. And this is a static let this thing, oops, which is a CG float. Yeah, let's do 4. So for every 4 points we move, we'll move our happiness by 1. And we could play with this constant. This is part of the reason I'm putting it out in a constant. We could play with this number until we got the feel that we thought felt right for changing our happiness. Okay, so we got our happiness change. So if the happiness change is not 0, so if the happiness actually changed, then I'm going to change my happiness. Happiness plus equals the happiness change. Okay? I'm also going to do that reset thing. So gesture dot set my translation to CG.0 in my face view. Okay? So I'm resetting it so that because I'm changing my happiness every time it changes, so I'm going to constantly be resetting it so that it's incremental. Okay? And then, of course, we need to have the default case, which is going to be canceled or failed or began, and I'm just going to do nothing in that case. So any other state that is thrown to me, I'll do nothing. All right, so let's see if that works. So let's run. Here we go. So now up is happier, down is sad. Up, okay. And we can still, of course, oops, sorry, do this. Okay, so these gestures, they don't look the same. Okay, they don't start the same. This one's a 2-finger 1. Okay, and this is a 1-finger 1. So the system can easily tell the difference between which one's going on. And iOS is very good at telling the difference between different gestures starting. Okay? So everybody got that? So we did a lot of different kind of gesture handling there. We added one in a storyboard. We added one in code. We handled one in our controller. We handled one in our face view. One is scaling and pinching. The other one was translation. So hopefully between those two, you can look through that code and kind of get a good feel for how the gestures go. All right? Okay, good. So we do have some time left. I'm going to get started on the next topic here. Before I do that, because I'm going to get interrupted in the middle, let's talk quickly about what's coming up. So on Wednesday, I'm going to continue the slides that I'm going to start in a minute here about multiple MVCs, and then I'm going to do a big demo creating multiple MVCs in our happiness controller. Okay? And again, time permitting, at the end of Wednesday, I'll do another topic, view controller lifecycle. Friday, hopefully it will have this instruments thing. And then next Monday, I put auto layout question mark because I was telling you I was going to do auto layout sooner, but I keep putting it off. And I might put it off again. We'll see. But I won't be asking you in your homework to do much sophisticated auto layout. So even in assignment 3 is very little. OK, so next topic, multiple MVCs. So you remember this picture, I hope, which was at the end of the MVC talk, where I talked about how if we want to build a big app, we're going to do it by putting multiple MVCs together. Okay? So we're going to zoom in here and take a look at exactly how that's done. Okay? How we're going to make combine multiple MVCs. Okay? So you see that MVC right there, the purple one at the top. That's an MVC, and you can see that its view is actually made up of other MVCs. All right? So iOS provides some controllers for MVCs that have other MVCs as their view. And the 3 we're going to talk about today, by the way, you can build your own. I'm not going to talk about that today. You can build your own controllers that have MVCs as view. But I'm going to talk about the 3 that are provided in iOS, which you're going to be using in this class, which is tab bar controllers, split view controllers, and navigation controllers. Okay? So these are just controllers. They're subclasses of UI view controller. And their view is made, they draw a little bit in their view, but then most of their view is what other MVCs draw. So the kind of MVCs are part of their views. So let's look at tab bar controller. It's probably the simplest one of all these. You've seen tab bar controllers. You see it's got the 4 tabs along the bottom in this one. This is the health app, I think. And all that happens here is when you click one of those tab buttons at the bottom, the top gets replaced with an MVC. An entire MVC is controlling that top. In this case, it's some sort of dashboard MVC, your health dashboard, okay, is being presented at the top right here. And the icon and the title that goes along with the dashboard down there is actually gotten from the dashboard MVC. In other words, it's not a property you set on the UI tab bar controller MVC. You actually just have a property on your dashboard MVC. It's called tab bar item. And inside tab bar item, if you go look it up in the doc, it's got things like title, icon, etc. Things that the tab bar controller needs to put a nice tab on the bottom for your dashboard MVC. So as you can see, it's very object oriented. Okay? Everything is contained in just this MVC. And so if I press on a different tab, okay, maybe the second tab, then this is a totally different MVC that takes over the top of the screen. This is the health data MVC. And you can see that it's got a different icon and text down there, right? By the way, if there's too many tabs along the bottom there, like I think you get 5. If you go to 6 tabs, then iOS will automatically let the user manage which ones he wants down there. It's pretty cool, okay? So you don't ever have to do anything. You put as many tabs as you want. I don't really recommend more than 5 tabs here, by the way. You know, for users, it's like, wow, I have to manage my tabs down there. I don't want to do that. It's just you're asking your user to do more stuff. So hopefully you can fit in 5. And so we have other MVCs as well. So there's the sources of health data, I guess, and your medical ID tab. And so this is a very simple thing you can understand. You've got this UI tab bar controller. It's a controller of an MVC. The view is the little tabs along the bottom that it's drawing and the MVCs on the top. Everyone understand what I mean now about an MVC whose view contains other MVCs? All right, so let's look at another one that does that. Split view controller. So split view controller takes 2 MVCs and it puts them side by side. Okay? It puts the one on the left, kind of a known, well-known width there, but you don't care what that width is because hopefully you've got auto layout, and so it could be any width you want or any height you want, like this. And then it puts another one on the right. Now, we call the MVC on the left the master in the split view, and we call the MVC on the right the detail. Now, here I've got a calculator and a calculator graph. Your assignment 3 is going to be to build this, basically. It doesn't have to look exactly like this. Okay? I've made a simple looking one here. But it could look very much like this. But you do have to use a split view controller. So this is what it looks like. Now, of course, this is only happening on an iPad. Now, we're going to talk about, when we talk about auto layout, we're going to start talking about size classes. So different devices have been grouped into size classes. And the sizes basically are regular, so regular width and regular height, or compact, width and height. So an iPhone, all the iPhones except for the iPhone 6 Plus in landscape are compact, both vertically and horizontally. Okay? The iPad is regular width. Okay? Now, that's of the whole device, but the MVCs inside also will have a certain size class. So this side-by-side business can only happen in a device whose size class is regular width. So that's the iPad in both landscape, it could landscape and portrait could be that, and the iPhone 6 Plus in landscape. Okay, so split view is only going to do the side-by-side business there. And if you rotate the iPad, then the master disappears. But it can be swiped out. If you just swipe from the left, you will, and of course, when you rotate, the only one that's there is the detail. You don't see the master. But if you swipe out from the left, then you get to see the master as well. Again, side by side. Okay? And if you touch the detail, it'll make the master go back away, and then you can swipe it. So you can bring the master out or not. Okay? That make sense? So that's the split view controller, kind of how it's arranged. But most importantly, I want you to understand that, again, it's two MVCs that are the view. Now, the split view draws nothing in its view, except for maybe that vertical separator line. Okay, there's a vertical separator line. That's probably drawn by the split view controller. But otherwise, it's only drawing whatever the MVCs draw. So it doesn't even have any drawing like on the bottom like the tab bar has. Okay? So the next thing I'm going to talk about, I'm going to start this next time, is navigation controller, which is a very powerful one. It draws at the top a little title and some things that can draw even around the bottom. And then it can display any number of MVCs. Okay? So we'll pick up the navigation controller next time. And in the meantime, if you have any questions, I'll be here as usual.
For more, please visit us at stanford.edu.